Hey y'all. So today's objective is box plots, IQR, and outliers. We're going to talk a little bit about all three. So the first thing is, this is a picture of a box plot. It's a box and whisker plot because there's a box and whiskers. So to make a box and whisker plot, you need a 5-number summary. 5 numbers. And those 5 numbers are the minimum and the maximum, the median, the quartile 1, and quartile 2. So those are your 5 numbers that you need. And each quartile is a fourth or 25% of the data. So this whisker is a fourth. This first box is a fourth. So each section, it's called a quartile. Quart means 4, so each section is a fourth of the data. They might not look equal, but they do have the same number of data items in that section. The IQR stands for interquartile range, and so if you know what range is, you know it means to subtract. So the IQR is the third quartile minus the first quartile, and this represents 50% of the data in the middle. So the IQR is this box right here, from here to here. That represents the middle 50%, and you want to use the IQR when you're talking about data with outliers because it just talks about the middle 50% of the data. And then again, the range is the maximum minus the minimum, and that gives the whole spread of the data. So the IQR is the middle, and the range is everything. All right, so let's make a box and whisker plot. In order to make a box and whisker plot, you have to have data. And the first thing you do with the data is you order it from least to greatest. And then you need to find your median. So to find the median, you cross off the top and the bottom, and in this, our median is right here. So it's 13.5 because it's right in the middle of 13 and 14. So if you add those together and divide by 2, then you find the median. To find the first quartile, you must find the median of the first half of the data. So we broke our data in half, and now we have to break the first half into another half. So this would be right here. So we have 4 numbers, 1, 2, 3, 4, 10, 12, 12, 13. And so the middle is right here. So the first quartile is 12. To find the third quartile, we do it at the second half of the data. So we come over here, and we have 14, 15, 16, 20. And so the half would be right here between 15 and 16. So the third quartile is 15.5. That's in between 15 and 16. The minimum number is 10. And the maximum number is 20. So as you can see here are 4 sections. Remember I told you they may not look equal, but they're equal numbers. So we have 2 numbers, 2 numbers, 2 numbers, and 2 numbers. So that is what we mean by equal section. They're a fourth of the data. Once you have these 5 numbers, you can plot your box plot. So I have a number line over here, 6 to 20. And I'm going to put a dot at all of these values. So 13.5. 12, 15.5, 10, and 20. And then you make your box plot. Whoops. So I hope you can see it goes all the way to 20. So this is just a quick example of how to make a box plot. You find your 5 numbers and then you plot it. All right, this next example, I'm going to show you how to answer questions using a box plot. So I have a box plot here, and I've told you what they all are: minimum, quartile 1, median, quartile 3, maximum. So now let's answer some questions. Question number 1, what's the median? So in this box plot, the median is right here above that, so the median would be 8. All right, straightforward. What is the range of the data? So we look at the maximum, which is 12, and the minimum, which is right here. Now some people will think you're going to do 12 minus 0, but the data stops at the minimum, which is 1. So 12 minus 1 is 11. The IQR is the third quartile minus the first quartile. So we have quartile 3 and quartile 1. This is 9 and this is 6. So 9 minus 6 is 3. Now number 4, what percent is above 9? So we're looking at what percent of the data is above 9. And we look right here. There is 1 whisker above 9, so it's 1 part, so that is 1/4 of the data. And we know that 1/4 as a percent is 25%. So this is 25%. I hope you can see that, 25%. The last question is, what percent is between 6 and 9? So we know between 6 and 9 is right here. And that is 2 sections, so 2/4, 2 out of 4 sections. And we also know that that's the interquartile range. And so that would be 50% of the data, 50%. All right, so example 3, determine if there is an outlier. So we're going to use the IQR to determine if the outlier. People have asked, how do you know if that's really an outlier or not? Well, mathematically, this is how you calculate it. First thing you have to do is find the IQR. Then you're going to multiply the IQR by 1.5. By 1.5. You're going to take this number, whatever you get, the product, when you multiply the IQR and 1.5, and you're going to add it to the third quartile. And you're going to look for numbers above, and then you're going to subtract it from the first quartile, and you're going to look for numbers below. So let me show you an example about what I'm talking about. Let's use the data from the previous example. We knew the IQR, or here's some data. The IQR is 3.5. From this data, the IQR is 3.5, the first quartile is 12, and the third quartile is 15.5. So the first quartile is here, the second quartile is here. Then we are going to multiply, so we found the IQR, then we're going to multiply it by 1.5. When you multiply it by 1.5, you multiply the IQR times 1.5, and we get 5.25. So that's step 2 right here. Step 3 is we add it to quartile 3. So whatever quartile 3 is, 15.5. So 15.5 plus 5.25 is 20.75. And then step 4 is we subtract it from quartile 1. So quartile 1 was 12, so we do 12 minus 5.25, and we get 6.75. So we found the IQR, we multiplied it, and then we add it, we subtract it. It seems like a lot of steps, but you'll get used to it. Now we have to look for our data. Do we have any numbers above 20.75? Well, our highest number is 20, so the answer is no. Our lower value is 6.75. Do we have any numbers lower than 6.75? And our lowest number is 10, so the answer is no. Therefore, there is no outlier in this data set. All right, so here's another example. Determine if there's an outlier. Here are some data. 2, 2, 3, 4, 5, 5, 6, 6, 12. So you might be thinking, oh, 12 is an outlier. Well, let's mathematically test it out. I've already found the IQR for you. 6 minus 2.5 is 3.5. Again, weird. And then the IQR times 1.5. 3.5 times 1.5 is 5.25. Again, it's not always going to be. It just happens to be. So we have to find the IQR, then multiply by 1.5. So we add it to the third quartile. 6, the third quartile, plus 5.25 is 11.25. And then we subtract it from the first quartile. Minus 5.25 is negative 2.75. So we look at our data. Do we have any numbers above or any numbers below? So this is negative, so we're probably good with that. But do we have any numbers above 11.25? And yes, we do. So that means 12 is an outlier because it is greater than 11.25. Once you have the IQR, then the steps are easy. All right, so here's a you try. Is there an outlier? So here's your data. You have to order it, and then you have to find the special statistics. But I already found Q1 and Q3 for you. So you can find the interquartile range, and then I kind of guided you through it. So I want you to finish this U-try on your own to determine, is there an outlier? In this data, is there an outlier by finding the IQR, putting it here, multiplying it, and then seeing, is there anything above or anything below? And we will go over this problem tomorrow in class.